Cool. I'm here with Frederic from Polar, and Polar Signals maintains has lots of people from the Parsi queue. I'm not sure how to pronounce it, but cool EBPF, the Berkeley packet filter kind of virtual machine in Linux, and they allow you to profile your code a lot easier.
Yes, it's pronounced parka.
Parka.
Like, you know,
cool.
The jacket.
Vest over the jacket.
Yeah,
that's awesome.
Yeah.
And yeah, we're gonna probably discuss open source, open core monetization. That tends to be where these conversations goes. But Frederic, all up to you.
Yeah, I think kind of my biggest question, I think, for you is like with open source and everything open source, or even with open core businesses, I'm curious how intentional you potentially might have been about, you know, the really large cloud providers that maybe have the ability to kind of take over the market share pretty easily, right? I don't know. I mean, AWS is the one that comes to mind, and where it's happened several times. I'm curious if there's something that GitLab did intentionally, and what do you think that might have been?
Yeah, I think one thing we do is like to have to put some of the value in proprietary code so that can be forked. I think there's other startups that were all open source, like Sentry, for example. They were completely open source for a very long time. Really commendable, really awesome. But also I think I think they ended up closed sourcing their code, although I'm not 100% sure. And then there is a risk of forking commoditize. I do think that the risk is higher for infrastructure software. We consider ourselves application software. And this table kind of lists the dimensions we look at and how that's different. So I think companies like an Elasticsearch are much more natural fit to fork and commoditize for a hypercloud than a GitLab is. Doesn't mean there's zero risk. It's just a way to look at it. I think your project, yeah, is it infrastructure or is it not? I think if you look at the interface, there is a graphical user interface, I think, or not. Do you use Grafana?
Yeah, we have our own.
You have your own, so that helps. Drives little compute, drive lots of compute. I assume you're trying to drive as little compute as possible because that's less overhead for the user, so that's good. Multi-tenant versus single tenant. I think yours is more single tenant.
Yeah.
Although you might launch kind of a SaaS service with an interface, right. So that would help. So consider doing that to reduce it. Feature richness. Of course, you have a lot of features, but I'm going to say few features compared to something like GitLab. And ecosystem activity. Lots of contributors or few contributors. Let's have a look. No, it's taking a while. I would say few contributors. So that's how I would rank you on those dimensions. So it's not super clear cut.
Yeah, that makes sense. The other thing that we were really interested in is kind of hearing your opinion about. So one of the major things that kind of drives people to want to use a product like ours is kind of either to save on infrastructure cost, because simply by having the data of like where is your CPU time spent, where is your memory spend, allows us to actually do something about it, right? And the other one is to kind of improve performance, and that can have kind of various forms. For one that we're seeing a lot is e-commerce companies that are trying to like keep their latency low, because that drives conversion rates. But one other kind of aspect to performance improvements we've seen, which is why I was super interested in talking to you, is in like continuous integration environments. Like we've seen a couple of companies, I'm not sure they want me to name them publicly, but that have kind of used this software to optimize not the CI software itself, but the tests that are running on that CI infrastructure, and therefore kind of increasing developer velocity. I'm curious, like what your thought is on like CI speed and developer velocity, and then also kind of if there's a way to our project is relatively low level with eBPF, right? So how could something like our project potentially integrate with something like GitLab CI runners or something like that?
Yeah, that's interesting. Regarding CI, I tend to think that there's lower hanging fruit. The most obvious way to make it faster is parallelization, like just splitting the tests over more cores and multiple machines. Another technology that's interesting is to kind of save pass state between the different phases better, so make it very quick to download packages or save state from an earlier thing. For example, if you're making a model. Companies that done great work in both areas are Circle CI and Semaphore. I think they really focused on that performance. And I didn't see kind of code profiling as a way they used. At the very extreme, you'd go to something like Bazel from Google, which is a DVM technology. That's really good at kind of parallelizing code and stuff like that, but it's a handful to use. So I see it could be helpful. I think, look, developer productivity is super important. If you can reduce the time of test, super important. It's certainly a way to do that. I would reach for other ways earlier. But it all depends how usable it is and everything else.
I think that makes sense. And like the kinds of companies that we've seen get to this point are the like really advanced tech companies.
Yeah, the Bazel users, Google and stuff like that. Yeah.
It's these kinds of users for sure. I mean, like I was kind of hinting at this, but like, is there a way to potentially I don't know, partner with GitLab or something to provide things like this, because it needs this kind of relatively low infrastructure access? Like, how would something like that work?
Yeah, so we're open for technology partnerships, and the code is open. Like, you can make merge requests. Now, if you're going to add a really big button in some obvious place for a feature that very few people will use, we will not merge that code. I think one of the most successful one has been with Gitpod. In there, we have a drop down somewhere like open in the web IDE, and they made the button into a drop down where you can also select Gitpod as an option. And I think that's been a successful partnership from both sides. So see where kind of in the interface, etc., your product is the most relevant, and maybe make a mock-up of like, hey, we'd like to add it like this. Is that okay? And hopefully one of our product managers and interface people look at it and say, yeah, that makes sense. If you don't need a change in the interface, but it's just don't know, we'll link in the documentation somewhere, like, hey, running into performance problems, consider looking at this. Or it's a feature you can add in the YAML file. Oh, you want to add Parka, just add this line, and this is a great recipe for it. So I'd start with that. I'd start with find the CI documentation, write the page about like making it faster. Like, I'm sure there's room for improvement, like link to all the amazing tech that people made based on everything else. Add yourself as well. And then say, hey, here's a great YAML script. And by the way, if you need support, here's how to reach, I don't know, our Discord or whatever you use. Probably that's an interesting place to start.
Mm-hmm. Yeah, that's definitely very interesting. Talking
about, like, I think you have two ways in which to use Parka. Like, you can focus on reducing cost or reducing latency, either in production for the end user or in test for the developer. Is there a third way to promote the product? Does it help with scaling? And I'm going to make the case and then argue against it. The case would be the faster your code runs, the fewer kind of servers you need to scale up. So for example, if you have contention on DB connections, that your code, you're kind of like profiling it and increasing the hotspots would really help. On the other hand, if I had contention on DB connections, I'd use a pooler. And if I use a pooler, really it doesn't matter how many processes there are anymore. So it doesn't really solve anything. How do you think about that?
Yeah, I think there's also this particular case that you mentioned. Yes, it's absolutely true. We have seen that, you know, pre-allocating memory, for example, is kind of the classic one that people find with profiling, right? And that can lead to improved performance, decreased latency, decreased resource usage. There's also kind of like sometimes these kind of tools also spin on, you mentioned like potentially using less servers, right? The interesting, like, it's almost like a socioeconomic thing where if you make things more efficient, we actually end up using more. And so like that's why like sometimes these kind of tools, and we ourselves a little bit as well, that's kind of what the name plays on, like say that by reducing potentially the amount of servers that we're using, we're like helping the planet, right? But the reality is that sometimes this isn't the case. But on the other hand, we have had conversations with a couple of hyperscalers where they've used technology like this, and I am specifically talking about hyperscalers, because of the scale that they were working on, they didn't need to build entire data centers. And this was particularly important when during like the beginning of the Corona crisis, or even right now, there's like chip shortage, and it just, there wasn't any other way other than optimizing code. There was no way to purchase new hardware. So it can work, but it kind of also depends on the incentives. Yeah.
Cool. No, that makes sense.
Yeah. So part of our like project is the way that we managed to make some of this work, because we are dealing with a lot of data, is kind of the storage. So my background is actually is I've for the past couple of years I've worked on the Prometheus project, and I've worked on everything from storage to Kubernetes integration, things, all of these things, and in this project we also have a really big data problem, which basically forced us to kind of build our own database, although it's a bit of an overstatement because we're building on a lot of technologies that were already established that we could use as libraries, such as Parquet and Apache Arrow. So, we didn't have to build things like page caches or file layouts, all of these things that can take a lot of time. But my point being, this is dealing with all of this data is a core part of the work that we do. How difficult has it been for kind of GitLab to deal with like large volumes of data, and how did you potentially, if you did this intentionally, kind of hire for people with that kind of background? I think this is one part where we kind of struggle to find someone who has the right kind of experience, because building databases is not exactly something a lot of people do.
I think it's very hard. There's we haven't done that. It is an important part of our strategy. We had a development department meeting this morning, and we said, hey, we probably need a ClickHouse team, because kind of using Postgres for kind of the high volume data metrics and logs and traces and everything else is not gonna work. So we're starting ClickHouse team. I'm not sure. Happy to get your opinion on ClickHouse. I'm curious. Would you probably would that be, if you'd had to use an off-the-shelf technology, would that be something you'd go for, or what do you think of that project?
Yeah, I think ClickHouse is super interesting, and we actually considered it as well. The big reason, or there are kind of two reasons why we didn't go for ClickHouse, at least for the open source project. One, we really wanted to have that Prometheus experience where everything's in one binary and it's incredibly simple to set up and get started with, because you just download the binary and get started. So that was kind of why we needed to write something in Go, because that's kind of what everything in this ecosystem is written in. And then the other reason is, and this is super similar to, maybe you're familiar with the Influx IOX project. They're also basically building a columnar store at InfluxDB right now. And the reason why ClickHouseDB didn't necessarily fit the bill very well is because we have all of this kind of high cardinality labeled data, and ClickHouse doesn't really have good support for these kinds of data models, just like with Prometheus, where you have labeled data and you can kind of search on every dimension. And the way that other columnar databases have solved this, but they're all kind of closed source. They didn't talk a lot about it publicly, but the way we think the folks at Honeycomb might have solved this is by kind of dynamically creating columns whenever you've seen a label name for the first time. And that's essentially the same strategy that the Influx IOX team ended up going down, and that's also what we ended up doing. And the reason why this is important and why you need to do it this way is because if you have all of the label data in a single column of the same label name, you can actually do a very efficient search for this data. The only kind of data type that you have available for something like this in ClickHouse is a map type. And the problem with the map type is that you kind of store it more like a traditional database, like in rows, basically, all of the entire map per row. And that doesn't really work because we want to be able to only read the data that we need to. That's kind of the point of the column store.
So you have something like server name and then like a gazillion server names. So you'd create a new column called server name on the fly when you ingest that. Okay, that makes sense. Exactly. That Influx project, I haven't heard of it. I heard IOPS, but that's probably not what you said. What's the name of that project?
Yeah, IOX.
Cool. Iron oxide. Okay, cool. Thanks for that. I'll check that out.
Yeah. it's definitely a super interesting project. Actually, I met with Paul Dix, the CTO of InfluxDB, about it. If it had been, so this project is also still under heavy development and isn't really like they're using it internally, but it's not really well accessible outside of InfluxDB just yet. And so if that hadn't been the case, we would have potentially looked into using their project, but yeah, isn't available yet.
Cool. Thanks for that context.
Yeah, but yeah, I agree. I think this is a difficult problem that a lot of companies are struggling with and trying to solve. Hopefully, you know, the work that we've put in is kind of going to be worth it in the long run because of exactly what I just said.
Hope so too. Thanks so much for the call.
Thank you.